All right, so hi guys. So this is going to be our first in-class meeting this semester for lecture. I know it's quite sudden change, but this is something we gotta do. And I thought that this is better for us to have a real-time in-class lecture setting. And also, I know you guys taking a lab classes from me, so you can ask me any question about the lecture or lab. And these times in the lecture too. Okay. All right. So let me actually spend more time today actually on explain how we're gonna do this lecture this semester. Okay. So we're in the Monday and Wednesday and Friday. I'm assuming you guys in Friday section over here. So you only need to attend once for this your in-person class lecture. And the other 2 days, so if you're in Friday, so for example, for Monday and Wednesday, what you can do is it's not going to be a real-time online meeting. You can watch me through that video, but I'm gonna record the lecture on Monday and Wednesday with other two-part group of students. And later that the same day, on the maybe afternoon or near noon, I'll try to post recorded lecture videos on campus. So it's not real time online meeting you have to attend. Only thing you have to do in real time is your pod days, which is Fridays. So those students in Monday or Wednesday pod day, they only need to come Monday and Wednesday. But the other 2 days, you will need to wait for the posting of recorded lecture videos on the campus, and then you can just watch anytime you want. But here's the one thing I want to recommend here. We have a canvas capacity is about 1 GB. I did a bit of test run yesterday and on Wednesday to the recording, and also I tried to estimate the recorded lecture videos file size, and it's approximately about 300 megabytes, 400 megabytes. Is there any computer science major here? No. Okay. But if you can do the math, this is about 1,000 megabytes. So that means maybe 2 or 3 lecture videos will be out on the campus, okay? And then we are out of the space on campus. So what I'm gonna do is I'm going to erase the previous one to get the new one out, okay? That means I want you to download the lecture video as soon as you see them on the campus, okay? So you can just keep them in your computer or laptop as well, okay? So you don't have to worry about missing any lecture video later time when I have to erase the previous one to upload a new one because of the limited capacity here. So here's the thing. You can download this. If you go to Canvas, this is maybe Canvas homepage window. You can look at the left side of the window browser. The one of them is says module menu. So if you click the module menu, I hope you guys already know this, but I'm going to do this anyway. The module menu here, if you click this one, you're going to see a bunch of class material, and also, like you did for the lab course, you can find a short video like that might be helpful for your writing a post-lecture. But there, for lecture, your homepage, Canvas homepage, you'll be find the lecture video. So you can click it, whatever the name is, and then if you click it, you'll see all of a sudden the video browser will pop on the canvas, and you're gonna just press this play button, and you're gonna watch the whole video. Okay, and then if you look at the top of it, there's the title of the video, and like it's I think MP4 file, but you can just click this file or do automatic downloading. You guys already know this, right? So make sure you guys do this. And here's the important message I want to tell you. This is for us. So I'm gonna record our lecture every week. Okay. So you can download it. You can watch anytime you want. And maybe one of your friends might forget to download it. So you might ask for hey, did you download the lecture videos? And you can share it. That's fine because he or she is what our classmate. But this is obviously Troy University's property. So you cannot share that with other people outside of Troy University. That's very important. Does it make sense? Okay, perfect. So make sure you guys do this, but you can definitely share with your classmates. Okay. Actually, I do have another lecture, so you can also share it with the classmate in other that section. They're also in Monday, Wednesday, Friday, started 11. They don't have a Friday in-person lecture on these two. So they only need to attend either Monday or Wednesday, and they can wait for the Monday or Friday or Wednesday, Friday for online lecture video posting on campus, like we're doing this semester. But you can also share the lecture video with them. They might be slightly different, but they can also watch the video in another section as well. So I'm going to try the same thing on this week to do the same for you guys as well. Sounds good? Okay, perfect. So as long as they're in our course, our lecture course, that's totally fine by me. Okay, but please do not share it with someone else who is not our Troy University member or student. Okay. All right. So there's a couple more things I want to mention here. I'm still working on making a syllabus. So, but I can tell you some of the things I decided already. So I'm gonna send out the finalized syllabus hopefully this weekend or early next week. We have a Labor Day, by the way. Anyway, so and then I'm going to finalize the syllabus. I'm gonna post it on campus. But meanwhile, I just want to tell you one thing that I think I'm sure I will do. So I believe we're supposed to have 3 midterm exams this semester, right? And 1 final. I'm gonna make it 2. We're going to have 2 midterm exams. Okay, so you have like a first midterm exam coming a little later than what you thought before. Okay, because we only have 2, and then you're going to have only 1 final exam, obviously after your Thanksgiving. Okay, and then this is what I normally do when I teach lectures. Is here's the thing. I know there's a really good exam quality I saw in Dr. Gamer's syllabus. I'll probably do something similar, but it's probably better for you. So what you can do is you can drop 1 lower midterm exam score can be replaced. It can be replaced by percent score of your final exams. So what I mean by that is you somehow did first exam, but you're too nervous. You're like, I don't know, for some reason you did a lot of studying, but couldn't pull it all off. So maybe you got 50 out of 100. Okay. But you did really much better in the second exam. You got 90. 90 out of 100. Okay, here. And then you also did really well on final. You did 180 out of 200. Okay. Only problem here is what? Your first exam score, right? And this will be replaced by your percent score of your final exam, which is what? If you can do the math, 180 out of 200 is what percent? 90%. So this 90% will replace your 50. That will be your total grade. So this is what I've been doing already for lectures that I've been teaching previous semester. I think I find this one very useful for most of people. This is really good because This is the last minute game changer. Think about it. The final exam is 200 points, obviously, big portion. It even replaced one of your lower midterm exam score. So this is a literally last minute game changer. So even though you did really poorly on, not maybe just 1 and 2, but still, if you do your best, if you study hard, you can nail the final exam. It also replace one of your midterm exam. That's a lot of points there. I can promise. So this is for sure. I think I'm gonna do it on the syllabus. I'm still working on the homeworks and assignments. I don't know what you guys have been doing on the assignments or homework previously, but you don't have to worry about them because I don't even know what they are actually. To be honest, really, that's really true. So first thing, what I'm gonna do, I'll try to contact Cengage company. You guys, I know, I've been working on the online form from the company, right? I'll try to make sure that if I can take it over from Dr. Gamero. So I want to keep it, but I'm going to see if it's possible first. And then I'll tell you later when it's confirmed, okay? But other things, all the details will be finalized maybe sometime soon. But this is something for sure I know I can tell you. I think still this is quite important for you to know. Sounds good? Do you have any questions about anything so far? We good? Okay. Perfect. So that is pretty much for what I want to talk about our lecture system we're gonna do this semester. Okay. You can always ask me any question during the lecture, after and before. It's totally fine by me. Also, whenever I go with some class material, I don't know how you guys been doing. I want to do this more. So you can see this, right, already. I couldn't do this online, but I'm doing this in person because this one. In real person class meeting, what you can do is you can ask me a question right away. Whenever you have a question, you can always stop me because that's my intention doing this anyway. So don't feel bad about stopping me for any time. Stop me. Hey, what are you saying over there? I don't get it, and I'll do it. That's totally fun. I actually love to do this. Do you know why? Here's the thing. What I think something I don't kind of recommend you guys do is active involvement, participation in the lecture. So it's just not me talking whole time. It could be sometimes whenever I talk about something important, then in detail, you might just listen to me very carefully sometimes. But if you have any questions, you need to involve it. And whenever you do this, what happens to your brain automatically is this one. If you just passively listen to me for whole time, what your brain does, go to sleep. Not literally you go to sleep, but your brain cannot focus on what you're listening to. It's boring. It's utterly boring if you're just listening to me for 40 minutes. Oh, by the way, there's a recorded video. Semester is a bit shorter than usual, but anyway, this is 40 minutes. Then I understand it's boring, but if you try to ask me a question, if you try to engage in my class talk, your brain will be automatically waking up. And you'll be more focused on the class material that actually save your time. Because think about it. Whenever you listen to my class, if you have a question, you gotta study for it anyway for the exam. If you wanna do well in the class. Why don't you do it in class right away? We have this opportunity. Makes sense, right? Okay. All right. So today, I don't think I'm gonna make a full-time lecture today because I wanna double check on my voice over there. And I tried to did it actually yesterday, but I wanna see my drawings on the board too. So I'll double check it when I post this lecture video on today. But let us do it a bit trying on chapter 2. So I want to go over chapter 2 briefly once more, if this all fine by you. So here's what I'm going to do. If you're watching me on the lecture video, you'll be kind of surprised that you don't see the PC slide. In this screen now, just heading me and this board, but not this one. So here's the thing. You can see me and this PPT slide in real time in your Fridays, right? But whenever you try to watch this video on Monday or Wednesday, you can put this either PDF or PPT file on the other side of your window in the screen on the laptop or computer, and just me doing this here. I did kind of the short practice yesterday. Whenever I try to shooting this PPT slide and this board together, that the quality of the video is too low because this distance is too far. So you can really see my handwriting over here, which I might think is more important to see. So what you can do in your home when you're watching this on campus, or you can download it and watch on your own PC. Make sure you got this on the other side of your screen. And also you can watch me talking here. I try, if I forget, please remind me, to either I'm gonna say page number of the PPT slide, if I'm gonna do anything on here, or I'm not gonna say some titles on it. So you can keep tracking the numbers, page numbers or titles. So you can just, me just talking, you can still see your PPT on your other side. Okay, so that's, I think, better. Because this still will be better on the video. You can also looking at the PPT on the other side. You can try to manage your time. Okay, sounds good. So this is also I want to be properly recorded so the people will watch this video today so they can do the same. But anyway, here's the point. All right, so chapter 2. Here's the thing. There's a couple of things I looked over Wednesday and yesterday. The couple of things I think is quite important, so I'm gonna go over once more. And then probably sometime next week, I'll just jump into chapter 2 right away. So now we are on chapter 2, covalent bonds and acidic bases. So let me. So here's the thing. The first part of the chapter 2 talks about the electronegativity. So electronegativity is simply this one. Electronegativity is simply the tendency, like how much each individual atom wants to pull the electron toward themselves. So if it's a highly electronegative, it simply means they have a much more highly dominant position to grab the electron into their side of the space. So for example, if you have this type of bonding here, okay? So just whenever you're going to have an exam, either online or on site, you're going to have a periodic table, right? So this is a kind of review from your Gen Chem 2. Whenever you see on the right top corner of your periodic table, except the noble gas for sure, will be what? Electronegatively high. And the other side, your bottom left side corner of your periodic table, they have very low electronegativity. So this is where you can find, obviously, fluorine here. So whenever we get this, this is kind of a bond between these two. Somewhere between ion and covalent bond, but more covalent bond. You can do this by doing dipole calculation later. We did on Gen Chem 2. But that means, so if you recall your covalent bond here, or other type, you can try to guess there's a space where they're going to share for this electron share in that space. So that simply means, if I make it more precisely, what happens is they're going to be not in the middle. This is not the case, because if this is more electronegative than hydrogen, they're going to be staying right here. Okay, so this is sort of like this type of bonding. Okay, so this is, I'm pointing out, I know you already know this too from Gen Chem 2, but I'm pointing this one out because this is something we gotta do so many times this semester. You're going to see some the fluoro groups or hydroxy groups later on. They will do this type of mechanism in other organic chemical reactions. So this is why we're going over this type of introductory chapter first before we move on to the actual chemical mechanisms there. So I think this is something I just want you to know. I'm trying to remind you guys, so if your dipole moment is too big, the gap between Pauling scale, the numbers, is too big, maybe more than 2. That makes automatically become ionic bonds, which is normally can be found in where? In metal cation and non-metal anion, which you can find it on the left side of your periodic table. On screen is actually right side, I'm sorry. So the left side of the periodic table and right side of the table, they'll show you the big gap between numbers in Pauling units. So basic rule you can apply is if it's your cation part is metal, your anion part is non-metal, they tend to be in ionic bonds. But if you have a non-metal interaction, they tend to be located in only what? Or like what? Right parts of right sides of the periodic table. They tend to in a close position in the periodic table. That means there are not that different in Pauling unit numbers. Okay, so that's why they're going to have some more like covalent bonds. Okay? You guys know the difference between covalent bonds and ionic bonds, right? So ionic bonds is total separation of the charge by electron transfer. Electron just move. The covalent bond is more like they're finding the common ground to store their shared electron in the same space. You don't have to know, but once again, this is all because of what? Our orbitals, right? The orbital is where they can store the electron and can find by high probability to find the electron in a certain space. That's orbital. So this is actually been out on the exam, but orbital is not real stuff. Orbital is just the imaginary mathematically constructed space by human. So this is something you're gonna see in the later this semester. Why is it this? Why is the electron moving this way? But it's because the nature of the chemistry and the nature. Anyway, so anyway, we'll get to this one later this semester. But this is good enough for us to know, I think. So at least you should know what might be the molecular bonding or ionic bonding and so on. Oh, do you have any questions? I just reviewed. Please bear with me. I just emphasize this one as more because it's quite important. Dipole moments, really good things. So now in the polar covalent bonds and dipole moments, in this part in 50th slide, you don't really have to know much about the calculation because this is something you already did on GenChem 2. But only thing that I want to know is directions. So how you can point out the direction of the dipole moments. So normally what you can do easily is you try to put the more electronegative parts. So here's the thing. It's actually kind of common sense if you think about it. Obviously, the one that is more electronegative will have more numbers of electrons. Especially, they tend to store the electron on themselves, and they tend to have several numbers of a lone pair too. Then there's the direction of the dipole moment we're heading to, the way you can find more electrons. It's a lone pair with the electronegative atoms, right? So if you do the sum in the net, will make some direction of total in that specific molecule. Okay, so this is what you're seeing in this picture. Title is polar covalent bonds and dipole moments. But once again, for your exam, you don't have to know how to do calculation. It's just simply what? Your charge times distance. This is what we did already in GenChem 2, right? You did GenChem 2, right? Do you guys remember this? Actually, it's a long trip for you, or I don't know. Okay, anyway. So I think it looks good. So that's all you need to know. But most importantly, I looked at one of the parts in the section 2 that I want to go over again. The polar charge. Formal charge. Now we are in 50 slides. The title is formal charge for dimethyl sulfoxide. Here's the thing. Whenever you do the formal charge, what you can do, let me copy that real quick. Sure. Yeah. Okay, so oh, let me draw this. I'm sorry. So sorry, I want to do that clearly. Yeah, that's better. Man. So I'm sorry, this is also kind of blow my eyesight too. I try my best to copy it. So if you look at the PPT slide, you see those all calculation there, right? How many numbers of each atoms, what's the sum, unity by if it's in bonding. I mean, it's kind of what can I say? It's kind of common sense, but I think I can tell you the better way. This is what I also did on my Jenkins Tucson. Do you guys take Jenkins from me or I don't know, but this is easier way. This is easier way. Please trust me, this is much easier. You can do that too. You can do the calculation on that there. That also makes sense because your numbers in the electron by bond by 2, I mean, and also the ones in the atoms you need to add on, yes. But how about you just do this way? So if you look at this one here, the hydrogen that bond to carbon here, right? Okay. So this hydrogen now is what? Where is it? If you look at the periodic table, so if you're watching this video from the home, you also need to see your periodic table. It's number 1, right? Okay, so this one should have only 1 proton and means what? How many electrons? 1, right? So if you think about it, whenever you count for how many electrons does that specific atom has, you just need to circle it. Circle the specific atom around it. And there is only 1 dot you can find on it. That is where it belongs to hydrogen. You have another one on the other side to the carbon, but it's shared. The one that belongs to the hydrogen is only 1, right? So 1 proton now has only 1 electron. So the charge on this hydrogen should be 0, for sure. How about this carbon here? Whenever you circle this one around, carbon is where? If you can find the carbon on the periodic table, that's in the group 4. 1, so group is what? You know that, right? Vertical column, 1, 2, skipping the space, and 3 and 4, right? So carbon is group 4, right? You guys know this, right? So carbon 4, oh, you had a question, no, right? Okay. So carbon 4, but look at it. The electrons are on the carbon. If you circle this one, 1, 2, 3, and 4. So in the group 4 now have 4 electrons. Now it's good. So this is also net charge, formal charge 0. Same thing here and here. So now we see why sulfur now has positive charge. It's very simple actually. You don't have to do this in the calculation. Just circle this one here. Okay, circle this one here. So now you see the sulfur here, which is in group 6. So now this atom can't have 6 electrons to be neutral. But it only has 1, 2, 3, and 4, 5. Because there's a 1 lone pair down here. So 1, 2, 3, 4, 5. It should have a 6. It only has 5. So it's missing 1 electron. So electron is negatively charged. If it's missing 1 electron means this circle will make 1 plus forward charge. Okay? So we'll do the same thing on oxygen here. Oxygen is also in group 6, but it now has 7. 1, and 3 lone pairs, right? It's 2, 3, 4, 5, 6, 7. So it should have 6, but now it has 7. So oxygen in this molecule has 1 more electron than it should. So now we put in negative charge because it has 1 extra electron. So, oh, my screen turning yellow. I don't know. But anyway. So now you can see whenever you have a molecular, chemical structure of some compounds or molecule, now you can see by just looking at how many bonds on each atoms in the molecule and how many lone pair on the top of it, and find that atom in the periodic table and see which group they belong to. And then try to count the numbers of that, numbers of electron, and you can do plus and minus. And remember, electron is negative charge. So if you have more electrons, negative, less actually means positive. That's also very important. But so I want to point out here today. So I think move on. It's very quick. Okay. All right. This is already 30 minutes. Wow. Is it really? So I'll try to do one more thing. Okay. As I promised today, we'll be on the sound and notes on the coding today. We'll do more like resonance structure. Okay. So we're doing the resonance structure of the I want to do SN base. That's more important for your so I'll do cover resonance next time. I promise you. Let me just do SN base real quick, just for quick definition. I will stop here. Okay. All right. So here's the thing. So you see some difference, obviously, from your Jenkin 1 and 2 lectures and organic chemistry lecture. Is this one, especially in SN base. So when I look at this one compound as SN base, we actually have to apply a much broader concept that we have known from Jenkin 1 and 2. So normally, what chemists normally use is Bronsted-Lowry definition. So this is very famous. Most of the chemists follow this rule. Later I'm going to tell you something more, but I'll tell you why we sometimes don't want to use it. So in this definition, any acid molecules or compounds will donate protons. Okay, you can either say, as we're done in Jenkin 2, you can either say H plus or hydrogen cation. That doesn't matter. Hydrogen cation doesn't matter. But make sure it's just purely proton. It's something that's positive. Will make some changes in the medium and the chemical mixture. And the base will actually accept protons over here. Okay, so this is what we normally do for defining either if the compound is acid or base. But sometimes we need to do more. So very slight change. So it's not like a dramatic change in the acidity, usually measured by pH level. You know what the pH is, right? It's purely negative log of your concentration of a proton. But so maybe it's not that much of a big change in your acidity of something, but also do a little bit and very slowly. So this is why we need to bring in some concept of pKa and Ka. So sometimes we do follow the Lewis definition. Okay. So in here, we're only going to do this the other way, but we're going to change this proton to electron. So in Lewis, acid actually accepts electrons. Okay. And then base donates electrons. Okay. So in this way, you can have a much broader application. So you can, so maybe for certain chemical compounds, you can say if it's, you will tend to be confused if it's acid or base, or you can go to, yeah, if you want to, yeah. The acid or base, but in a Lewis, you can actually use even very weak or weak base, still can be defined in this definition, because all the chemical reaction is what? Technically, they're choosing to either break the bonds, making a new bonds, and that only possible by what? Doing transfer of electrons. So either making a much bigger molecule or making a smaller by breaking the bonds. But while you applying this application by Lewis, will be more comfortable for us to define. Almost everything can be divided into acid and base. But we still prefer to use this one because but for Lewis, sometimes it's kind of hard to apply. Not hard to apply. It's hard to define that specific molecule. Sometimes be able acid and base, only based on the electrons. Typically, what we choose to do is we just still try to stick on those two protons. That's more, what can I say, obvious. So there's no like a boundary where you can be, oh, is it acid and base? But if you stick to this one, you can find the how can it affect the compounds and why the chemical reactions more precisely. But we'll go. Sometimes what I need to tell you before I end the lecture today is we're gonna do this one over and over. So once we're gonna do some like this one for some time, but we can do this sometimes without just doing much with the proton. Maybe just with the electrons, but it's easier for us. We're gonna use this one. So this is something I want to tell you before we move on to the next part. So I promise you, the resonance test is also very important to know for us to know, especially for the later part of this semester. But this is also quite important, so I want to go over this one first. Okay, so I think I'll just stop here today. Okay, so thank you guys for coming. So I think the Monday is Labor Day, right? So probably not sure what we're gonna do on Monday, but the program Wednesday will come next week. So on Wednesday, you can wait for my recorded video on campus. Make sure you download it. All right, thank you guys. I'll stop here.